Kia ora tātou, welcome to this video where we will look at conjugate acids and bases and amphiprotic substances. So conjugate acids and bases, if we've got an acid like this, so we looked at this reaction in the strong versus weak acid video, we've got ethanoic acid here and it donates a hydrogen to that water molecule, and then we have the ethanoate and hydronium ions over there. So if this is the acid, the conjugate base, so every acid will have a conjugate base once it reacts, so the conjugate base of ethanoic acid is ethanoate. Conjugate base. So basically it's just whatever the acid turns into once it's donated a proton. And then in reverse, because this is acting as the base, water can act as an acid or a base depending on whether it accepts or donates a proton. This will turn into the hydronium ion. So the hydronium ion is the conjugate acid of water in that case. So yeah, conjugate acids and bases are just the whatever gets turned into once the acid or base has reacted. So let's have a look at this one as well. So we've got ammonia, which is a base. That turns into ammonium, which is going to be the conjugate acid, because ammonium can now act as an acid, it can now donate that proton. And I've done this wrong, maybe you would have seen that just before, so that would be OH minus. And so water, this would be the acid, because in this case it's donated a proton to ammonia, and this would be the conjugate base of water. So all you have to do with these conjugate acids and bases is just identify them. It'll give you an acid-base reaction, and it'll say identify the conjugate acid of the base in this reaction, and then you just need to identify what it is. So there's no explanations required for this one. Now, amphiprotic substances. So this is where we can have protic, meaning talking about protons, and then amphi meaning, well, I don't know, two. or more than one, or different options, I'm not sure. But this, we've got this HCO3 minus, which can react with water, and it can either donate this hydrogen or it could accept a hydrogen from water. So that is an amphiprotic substance, because it can either donate or it can accept. So it can act as an acid. If this was to act as an acid, it would it would lose that hydrogen ion, so it would lose the hydrogen ion and turn into CO3 2 minus, and then this water would be H3O plus, aqueous, or it could act as a base and accept a proton from the water, and then that would be H2CO3. And see how here I'm just changing the charge on the ion. So if we've lost a proton, then that means that we've lost a positive charge, so we become more negative, whereas here it's gained a proton, so it's going to lose that negative charge to become more positive. And so because we've gained a hydrogen here, this water will turn into a hydroxide ion, H minus. And that's it. So this one would just be like, it would give you an example of an amphiprotic substance, and you'd have to complete the reaction of it reacting with water to form either its conjugate base or its conjugate acid. Why not, just while we're at it, so in this reaction this is donating a proton, so this would be the acid, and this is its conjugate base. And you can pause the video here and identify the acids and conjugate acids and bases in this one. So if you pause it now, and I'll just run in and do it. So here this is accepting a proton from the water, so this is the base because it's accepting a proton. This is donating a proton, so it's an acid. This will be the conjugate acid, and this is the conjugate base. And it depends on what you use as your reference. I mean, if we looked at it this way round, we could say that this is the acid, this is the base, and this is the conjugate acid, and that's the conjugate base. It depends on your point of reference. But that's it. That's for, what did we just do at the start? yeah, conjugate acids and bases and amphiprotic substances. Cool. Thanks for watching. See you in the next video.